Hello, my name is Landon Warder. I'm a master's candidate at the University of PEI in Charlottetown. And this presentation, I'm going to talk to you about some work I've done on building a system in the coding language Python for processing garbage can audits off of Canadian dairy farms so we can develop a system for determining dose-based metrics, particularly daily dose antimicrobial drug usage rates for all these farms. So I think it's pretty standard for anyone in this conference to have a working understanding that antimicrobial use in food animals is potentially a source of antimicrobial resistant pathogens entering into human populations and causing far reaching health impacts. This relationship most of the time is dose dependent. So if we want to have a grasp on how antimicrobial resistant pathogens are entering the food system, it's important to understand how much antimicrobial is being used and where it's being used, how it's being used, those decision factors as well. So our current surveillance methods for chicken and poultry and pork are quite good, but when it comes to cattle, these are lacking. So that's where this work comes in. I'm going to talk a lot about dose-based metrics through this presentation. So these are preferred to raw masses because they allow for more even comparisons between drugs because it can take a different mass of a drug to lead to the same effect, just depending on how that drug works. The two I'm using for dose-based metrics are DDD-BOVCA and DCD-BOVCA. DDD stands for defined daily dose, DCD stands for defined course dose. If a drug requires 10 milligrams to treat an animal, then that one treatment means that 10 milligrams equals one course dose. But if the effect of that treatment lasts for 5 days, that one course dose equals 5 daily doses. So daily dose is based on duration, course dose is the actual number of treatments. The BOVCA subscript is in reference to a paper by Alain Aldet at l'Université de Montréal that was developing these conversion factors specifically for dealing with antimicrobials in cattle in Canada. These exist for all of the antimicrobials approved for use in cattle in Canada. So using these dose-based metrics allows for even comparison between drugs, but we also want to have an even comparison between farms. These are standardized into rates that we call an ADUR, or antimicrobial drug usage rate, and these are expressed per animal year. And we do them for both doses or daily doses and course doses. The objectives of this study were to first develop a system that can quickly determine dose-based metrics from garbage can audits off of dairy farms, then can also break up all this data into categories that are useful for public health reasons and antimicrobial stewardship, particularly a category of importance, the type of drug, and how it's being administered. The data that we used is from the CatNet Acer project. This is conducted on dairy farms across Canada. In this data set, there are 94 farms that had completed their garbage can audit when I extracted the data. In this garbage can audit, what they do is a grad student or tech will drop off a garbage can and do a pharmacy inventory at that point on the farm. And they'll instruct the people on the farm to toss every medication that is used in the barn into the garbage can once they're finished with it. So then the tech or grad student comes back 6 months later and counts everything in that garbage can and then reconducts another pharmacy inventory. And I'll get to why we have those 3 different measurements on the next slide. So yeah, 94 farms are included. The intention was to leave the garbage cans for 6 months, but this was done in 2020, and many times this needed to be delayed. The farms are located in the Fraser Valley, British Columbia, southeast Calgary in Alberta, London, Middlesex in Ontario, and throughout much of Nova Scotia. The results were recorded electronically on an iPad, and the data was stored on a cloud data service, and then they're processed through a Python code that I wrote. So the Python code is about 1,000 lines long, and it's not worth going through every bit. So I'm just going to talk about some of the challenges that came about with actually producing these numbers. If you're trying to measure the amount of antimicrobial used, um, and you're not actually measuring it from records, you would want the disappearance and the appearance. So the appearance you get from purchasing records or dispensing records, but we don't have that in the study. They're going to be added in future years, but we don't have them at the moment. So in this data set, we're only dealing with disappearance. So we have a garbage can audit, so the amount that's actually thrown away, as well as we can calculate the difference between the two pharmacy inventories, and that'll be another metric of the amount used. So I basically have three situations for how to do the counting. First is if there was one item of a certain drug thrown out in the garbage can, and at the first inventory, that type of drug, they had less than a full bottle or full canister, whatever, then I assume that it was that part unit that was used, so I don't count the full unit, I count the part unit from the first inventory. If nothing was thrown out, I default to using the difference between the first inventory and second inventory, but regularly this number becomes negative because the stock at the second inventory was actually higher than at the first inventory, so this has to be discarded. In all of those situations, we just use the garbage can audit as the amount used, just because it doesn't have to deal with the changes in stocking. To actually calculate a DDD ADUR or a DCD ADUR, this is the formula used. Quantity is the number determined by the algorithm from the previous slide. The format is just the size of the bottle or package, whatever. Strength and dosage, that ratio is the concentration. But in Health Canada records, many times the dosage that they report for the strength isn't actually a strength per mil or strength per gram, it's strength per format size. So this ratio just standardizes that down to a concentration. The conversion factor, this is where you determine if it's a DDD or a DCD. These are straight out of the supplemental figures from Alain Laudet's paper, and they apply to every drug that is licensed for use in cattle in Canada. There are issues with drugs that are used off-label in cattle that pop up every now and then. So lincomycin in calves is a common example. We don't have a conversion factor for that at the moment, but for anything that's approved, there's a conversion factor. The number of animals, we opted to use the total number of heads counted. So that's lactating cows, dry cows, heifers, and calves being pre-weaned. There was debate about using just the number of cows, but we settled on this. And the duration, that is expressed in terms of years. So, short of showing you all the spreadsheets that are produced through this, I opted to just give you an overview of what's produced. It produces three different spreadsheets, but the one that's most important for communication's sake is the executive summary. This produces a raw DDD, a DDD ADUR, a raw DCD, and a DCD ADUR for overall antimicrobials, and then also broken down for every category of importance, class of action, that being like whether it's a penicillin or a first generation cephalosporin or a polymyxin, just breaking them all up that way. Route of administration, the production phase, based on those four categories I mentioned, so lactating cow, dry cow, heifer, and pre-weaned calf, and then form being whether it's a bolus or a solution kind of deal. And if we're looking at just the histogram of the DDD ADUR, you get something with a bit of a right skew, but it's fairly normal, and we're seeing that on average, cows in this data set were being treated for probably about 5 days per year with an antimicrobial. That's the kind of information that gets conveyed about this, but you can go much more in depth through it. The work that we're still working on doing would be increasing the number of herds and time points. This is a multi-year study, so we'll hopefully be able to add. And there are more herds in the data set now than there were back when I extracted this data. It'd be nice to compare the garbage can audit to dispensing records, and that's some stuff we're also working on at the moment. And it seems like dispensing records will be a little bit higher, so it's going to be interesting to see those results. And then changes in denominator. That's particularly for ADURs, so The duration part is pretty standard, but it's whether you want to use all the head, whether you just want to use lactating cows, whether it should be dynamic based on the group that is treated with a certain type of drug, or whether we should just do it per 10,000 liters of milk. There's a bunch of options there that we're going to have to consider moving forward. Thank you very much for watching. Hope you have a good conference. I want to extend my thanks to everyone working at CADNet Acer, all the grad students and techs doing work in the fields, and all the professors who are helping us out with making sure that this program goes well. Thank you very much. Thank you for your attention. Goodbye.